Hello, in this video we're going to look at the limit definition of the derivative for some polynomial functions. So the first function we're going to look at is f of x equals 5x plus 8. So the definition of the derivative f prime of x is the limit as h approaches 0 of f of x plus h minus f of x all over h. And using function notation, f of x plus h means that we're going to take our x in this equation and replace it with x plus h. We still have our limit until we actually evaluate that limit and plug in h equals 0. We need that limit notation. Alright, so instead of x, we're going to get x plus h multiplied by that 5 plus 8. All of that makes up our f of x plus h. And then we need to subtract our f of x, just the original function f of x, all over h. And then now we just need to simplify our numerator. So let's expand, distribute the 5, distribute the negative. So if we distribute the 5, we get 5x plus 5h plus 8. And then distributing that negative, we get minus 5x minus 8 all over h. We do have a plus 8 and a minus 8 that are going to add to 0. We also have a 5x and a negative 5x that are going to add to 0. Everything that is left has an h. We've got 5h over h. Those h's will divide out, and then we can take the limit of 5. That does not rely on h any longer. It's just the constant value 5, so it doesn't matter what h is approaching, that is always going to be equal to 5. So our derivative of the function 5x plus h is equal to 5. And that makes sense. The derivative is giving us the slope of the curve at any given point x, and it doesn't matter what point x we look at, the slope of a line is going to be just that m value coefficient on the x. All right, now let's look at a parabola. So here we have f of x equals negative x squared plus x minus 5. We're going to do the same approach. We're going to plug into this same formula here. Our derivative is going to be, the only difference is we now have two x's. We're going to replace both of those x's. Now we do need to make sure and follow order of operations on this. This negative is on the outside of the square, so it will be on the outside of the square when we plug in the x plus h. Plus, instead of just an x, we're going to get an x plus h, still have that minus 5. All of that is our f of x plus h. Now we need to minus our original function f of x and divide all of that by h. Oh, I forgot. This is the limit definition, so we've got to have a limit on there somewhere. The limit as h approaches 0. All right, so we're going to take the same approach. We are going to expand that numerator as much as we can and then combine like terms. We do have a binomial squared, and we can use a little bit of a shortcut. If we have a binomial squared, that's always going to multiply out to the first one squared plus 2 times the first times the second plus the second one squared. Order of operations says we have to do that exponent first before that negative, so I am going to still have parentheses around it. So x plus h quantity squared is going to be x squared plus 2xh plus h squared. Here our parentheses aren't really doing anything because our coefficient on our x term is just a positive 1. If it were anything else, we would need to make sure and distribute that, but it's not, so we get plus x plus h. We still have that minus 5. Let's distribute the negative. That's going to give us a positive x squared, a negative x, and a positive 5. All of that is still over h. Now we do have some common factors we can combine here. We've got a positive x and a negative x that are going to add to 0. We've got a negative 5 and a positive 5 that are going to add to 0. And it's fairly typical that you'll see those simplify and add to 0. Okay, now we need to distribute our negative to our parentheses at the front. So we'll get a negative x squared minus 2xh minus h squared. We still have from the rest of it a positive h and a positive x squared. All of that is over h. All right, our last piece to combine, we've got x squared and negative x squared that are going to add to 0. And one thing you will notice is that every term that's left has an h. That will always happen. We can factor that h out. When we factor it out, we get negative 2x. H squared, when we factor 1 out, is going to give us a negative h. And then we have a plus h. When we factor that out, we do still need to have 3 terms in our numerator. So we need to have h. If we factor it out, h divided by h is equal to 1. Now we have that common factor of h that we can divide out on the top and bottom. And we're left now with a polynomial, negative 2x minus h plus 1. We can plug in and evaluate our limit, and we'll get negative 2x minus our h value is 0 plus 1, which simplifies to negative 2x plus 1. So our derivative of negative x squared plus x minus 5 is negative 2x plus 1. So we can find the slope of that function at any point x just by plugging in that value of x. All right, let's do one more. Here we have the function f of x equals 4x cubed minus 1. So same basic approach. Our derivative is the limit as h approaches 0 of our f of x plus h is going to be 4 times x plus h quantity cubed minus 1 minus our f of x function, 4x cubed minus 1, all over h. Okay, same idea. We're going to expand, combine like terms. There is also a formula that'll help us to cube a binomial. If we have a binomial cubed, that is always going to expand to the first one cubed plus 3 times the first one squared times the second, so 3a squared b plus 3ab squared plus b cubed. All right, so we're going to do that to our x plus h quantity cubed. We still need to multiply that 4 by, so we'll put parentheses around it. Here our a is x and our b is h, so we'll get x cubed plus 3x squared h plus 3x h squared plus h cubed. All of that comes from cubing out that binomial. We still have that minus 1 left in the first set of parentheses, and we can distribute our negative to the second set, and we'll get minus 4x cubed plus 1. All of that is still over h. We do see that we can combine like terms. We've got a minus 1 and a plus 1 in the numerator. So when we combine like terms, those are going to go away. Distribute that 4, and we get 4x cubed plus 12x squared h plus 12x h squared plus 4h cubed, and then we still have that minus 4x cubed from the previous step. All of that is over h. Our 4x cubes, minus and positive, are going to add to 0. And again, just like every other problem that we've done in this video, we do have an h in everything that we can factor out. So if we factor out that h, 12x squared h becomes 12x squared. 12x h squared becomes 12x h. 4h cubed becomes 4h squared. All of that is over h. We can divide h on top and bottom. We're left with just what was inside the parentheses there. Now we can plug in h equals 0. So we'll get 12x squared plus 12x times 0 plus 4 times 0 squared. And the only term that survives that is the 12x squared. So again, our derivative of 4x cubed minus 1 is 12x squared. All right, I'll see you guys next time.